My name is Ankur, and we're going to talk a little bit about Braintrust. Fun fact, I've actually been working in relational database land for some time. I used to lead the engineering team at a company called SingleStore. It used to be called MemSQL back in the day when I joined, which was a lot of fun. After that, I started a company called Impura, which back in the stone ages of 2020 and 2021, when it was really hard to do ML, we helped companies use machine learning to extract data out of PDF documents. And then Figma acquired us, and I led the AI team at Figma. And basically at both Impura and Figma, it was really, really hard for us to make changes to our AI products without breaking everything. And so we had to get very good at doing this thing called evals. And I essentially built the same internal tooling at both companies. And then last year I was talking to Elad, who is one of our main investors, and he was like, hey, you've built the same thing twice. Other companies are starting to do AI stuff. Maybe they have this problem too. And so we talked to a bunch of these companies. All of these companies are customers of ours now. And the problem is very real. One tidbit, which I guess alludes to what we're going to talk about with ClickHouse, is when we were at Figma, we were trying to use Snowflake to do the data collection part of this use case. And the data team had done an incredibly good job over a year-long period of engineering the data pipeline to take 5 minutes to go from running an experiment to queryable in Snowflake. That's like, it's actually incredible. When I talk to most other companies, it's like an hour or a day. But if you're doing interactive analysis of AI stuff, which we'll do a live demo in a second, it's actually, that's just not, an engineer can't run something and then wait for 5 minutes. And so I started to see this problem then, and now we really, really face it. So just a little bit about what we do and kind of how that fits into AI development. I'm not sure how many people here are so-called AI engineers or working in AI. But basically, this is how all of the best companies build AI products. You start by using a flagship model. Nowadays, it's GPT-4 or Claude 3 Opus. And then you pretty much immediately ship something that's very broken to real users. And the reason you do that is the ways in which you think something is broken in AI are likely wrong. And the ways in which you think something works in AI is also likely wrong. And the only way you're going to find that out is actually shipping to users. So you ship to users, you collect feedback, and then what you do in a platform like Braintrust is actually collect the user's feedback into data that you can use to test and evaluate in your dev environment. And I'll show you a demo in a second of what that looks like. But basically, you create this loop around running evals that allows you to collect data, run evals, improve your thing, ship it to more users, collect more feedback, run it, and then eventually you care about stuff like optimizing cost and Llama 3 and all this other fine-tuning, all this other stuff that you see on Twitter and Hacker News. But really, I think like the core loop is around how you collect good feedback and how you run good evals. So let's actually take a look at that. So yeah, here's Braintrust UI. You can see there are some evals. I heard this new model called GPT-4o came out recently. So this is a fun use case. If anyone's interested in this stuff, I can send you a link to this notebook, and you can recreate this whole use case. It has to do with using text to generate some SQL queries and run them. But we can actually just run this thing. And let's see how GPT-4o compares, it looks like, to GPT-4. Great. So you can see the results are coming in. I haven't refreshed anything. Everything is real time. And Braintrust makes it super easy for you to actually dig into this data too. So even as it's coming in, we can go in and say like, hey, I want to look at the thing that improved. Database nerds out there, please observe how quickly the queries are running. There's some pretty crazy queries you can probably imagine that allow you to do these kinds of diffs. If you notice, like literally everything is instant. Wow. Yeah, you can again, hopefully some database nerds are enjoying this. You can scroll across these rows immediately. And so that's Braintrust. If we go out here, you'll also see the new experiment is here. The graphs are all updated. That all happened in real time. And then the last thing I'll show you, we talked about collecting lots of logs. Here's some fun logs. There's actually millions of rows in this log stream. You can also search for like random stuff, like find everything associated with this user's email. There's no email field defined anywhere. It's just like an arbitrary field in metadata that we allow you to collect, and then you can search for it. And so it's a pretty interesting database workload. And actually, I think we're going to talk about it in more depth now, but if you think about it, so we're going to talk about this stuff, how we use ClickHouse, blah, 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 technology. I'm going to share some areas where I would like ClickHouse to improve, which I think I've already complained to you about, but this feels like a good audience to do it. So anyway, if you think about it, it's actually a pretty challenging database workload. So every write is real time. And when I say that, I mean as soon as a write occurs, it's available for querying all the way in the UI. And actually, we try to take that one step further, which is it's not just available, it also updates the UI automatically. Every click is instant, and you can do this over an infinite history. And the way that we do that is actually by using 3 databases, which I don't want to do, but we have to right now. And if we kind of dig into this in more detail, these kinds of workloads are what you might think of as like hybrid OLTP and OLAP workloads. OLTP, online transactional writes. And it turns out that to actually get really good performance on these workloads, you kind of need a mix of relational database technologies. So here's how it works in Braintrust. I'm happy to answer latency or whatever detailed questions you all have during the Q&A, but basically, writes go straight to Postgres. And we actually do some non-trivial logic in Postgres to allow you to do fancy updates and role-based access control and all that other fun stuff. And then we actually instantly replicate the data to ClickHouse. And it might take a second. I mean, sometimes it's like a few hundred milliseconds. It might take a second. It might take up to 10 seconds, but actually that's okay. And the reason that's okay is that we control the app. And so we know for which queries it's semantically okay to be a little bit behind, like the graph of experiment progress over time. And we also know which queries have to respond in real time with up-to-date data. For example, the experiment page itself, all of the rows in that. And so we actually have some semantics built into our front-end framework that allows us to pick exactly how we query with various trade-offs. And then we use this thing called DuckDB in the front end as an embedded database running in WASM to actually do the last mile of analysis. And so some of the charts and graphs that you saw in the UI, as we were clicking around, some of the queries that update instantly, that's actually powered by DuckDB. And for us, one of the engineering challenges that we're always working on is, one, how do we coordinate information across these database systems which have different trade-offs? And two, how do we write code that allows us to operate against all of these systems? So another thing we've learned, I don't know how many of you are working on SQL-based systems that have non-SQL users, but SQL can often be actually a fairly crummy language for even analysts to be able to interact with data. As you saw in the search query I ran, we were accessing an arbitrary field in metadata without casting it to a string or doing anything like that. SQL is statically typed, and so we also actually have our own query abstraction, which is a very simple query language that compiles behind the scenes to these 3 different dialects. And so aside from allowing us to actually handle fairly interesting queries that are awkward, to say the least, to express in SQL, as an engineering team, it also allows us to invest in an abstraction that we can use to facilitate data across systems. So actually, one of our customers ran into an issue today where a query that we serve through Postgres was taking too long because it inherently doesn't match an index. And so with 2 lines of code, we were able to change that particular shape of query to run against ClickHouse. And then the query completes in less than 2 seconds, and the customer is happy. And that's due to building an abstraction like this. So the last thing, this is my sort of areas of improvement. And actually, I think our view is that over time, we'd like to consolidate how we're doing database stuff. We don't want to run 3 different RDBMS systems if we can. And so I think some of these things actually can help us enable that. The first is efficient JSON support. As far as I know, there's only 2 database systems that actually do this somewhat correctly. Snowflake does it very well, and then Redshift does it mediocre plus plus. But in Snowflake, there's a type called variant. In Redshift, there's a type called super. And basically what they do is they take semi-structured data, and then within a columnar segment, which is 65,000 to 10 million rows, they do schema inference and store it in a columnar format. And so you actually don't have to pay the storage trade-offs of using JSON, but you get some incredible query performance and compression. And so in the absence of that long-range filter queries that access JSON data even in ClickHouse, which is very fast at parsing and chewing on data, it's a lot slower than it theoretically can be. Another thing, we have this very weird thing where we actually make it easy for our customers to run Braintrust, the data plane part of Braintrust in their own cloud. I will say Mike and team have been incredibly accommodating of our weirdness, so thank you for that. On the flip side, I think we'd love to see the story around self-hosted, almost ClickHouse Cloud-like workloads being better. I know they're actually constantly making improvements on that. But in our case, for example, we offload the data to S3. But it's really tricky to do things like use an auto-scaling group and expand the number of nodes when we do an upgrade, or just deal with these kinds of annoying issues. So we're always excited about that. And then I think an interesting thing about ClickHouse is the QE, for those, I don't know how many people are tuned into these acronyms. The QE is insanely good, the query execution, but the query optimizer compared to, I would say, like traditional databases is very early along its journey. And so there are just some standard things. I'm sure people in this room have run into this, that many database systems solve for you very well, that they're just not part of ClickHouse yet. I think many of us, myself included, I certainly thought from your talk, because ClickHouse is open source and Mike is great and very flexible to deploy, we're willing to overcome all of these things and sort of do anything it takes to access the amazing query execution. But I think in the limit case, having a query optimizer that is capable of doing all the fancy algebra that Snowflake and Redshift and stuff will be really cool. So we're not super difficult to get a hold of. Our office is like 2 blocks away. You can stop by anytime. But you can also check us out online. You can email me at ankur@braintrust.dev. If you misspell it, I think it will still come to my inbox if we set it up correctly. And we're hiring. We also obviously want to work with customers. But yeah, we're basically hiring across the board.